Hello, good morning, good afternoon, good evening, folks. So this video is just an explainer on how to read the solar system object data table on page 2 of the new Earth Science or Earth and Space Science reference table. So if you're familiar with the old reference table, you can see that they've made some changes, right? They've made some additions. So for example, this column right here has the axial tilt, right? So basically is the tilt of the axis of the named planet, right? So for example, Earth is 23.49 degrees, okay? Or if you round it up to the nearest tenth, it's 23.5 degrees. And we can see, for example, Venus has a tilt of 177.4 degrees. Okay, so in any case, you have this information on this last column of the solar system objects data table. Okay, now going through the whole table itself, so in the first column, you have the celestial object. Okay, so that includes the sun, all right, which is not a planet. Okay, so remember that tends to be a misconception. The sun is our star that anchors, essentially, that anchors our solar system, and all the celestial objects or planets, if you will, orbit around the sun. Then in order, so you don't have to memorize the order of the planets. It's here in the reference table, right? You have Mercury, Venus, Earth, and then they include information on the Earth's moon. Then you have Mars. Okay. Now here, these are your dwarf planets, right? Ceres and Pallas, or Pallas, or Pallas. Okay. Now these are your dwarf planets. So they're not quite the size of the other planets, but they're fairly large. They're located in the asteroid belt. Okay. So you have to remember that uh Ceres and Pallas are located within the asteroid belt. Then you have uh, Jupiter, Saturn, Uranus, Neptune. Now, Pluto is considered a dwarf planet now. Okay. And then Aries. Okay. Now, one of the facts to remember is the first set of planets, the first four are your inner planets. Okay. Or also they go by the terrestrial planets. Okay. Now, and we'll see the characteristics on the other um, categories here. Then, after the asteroid belt, then you have your outer planets. Okay. Or your Jovian planets. Okay. So, if you can't remember, think about J with Jupiter. J Jupiter, okay, J Jovian. These are your outer planets, your Jovian planets, or you can also say your gas planets. Okay. Now, so this column, the next column has the mean distance from the sun in millions of kilometers. Okay. And as you go down, you can see that as you go further down the list of planets, the mean distance from the sun increases. And it makes sense. The further you are from the sun, the distance increases, the values increase. All right. Now, the next column is the period of revolution. So, in other words, how long it takes for a celestial object to take one whole trip around the sun. Okay. Or you can also say an orbit, one full orbit. right? Now, the important thing here is to notice underneath the units. So it could be in either in D for days or Earth days, or Y for Earth years. So if you notice the inner planets, Mercury, Venus, Earth, right? And well, let's just say Mercury, Venus, and Earth is in days, whereas now, although Mars is an inner planet, um, its period of revolution is almost about twice of Earth, right? So you, pardon me, uh, it's 1.9 years, right? Is 1.9 years. Okay. And moving forward afterwards, the two dwarf planets and then the outer planets is in years. And as you go further away from the sun, the time to take one full revolution is longer. That makes sense. Now, here, the next column is the period of rotation at the equator, right? So, how long does it take to make one full rotation on the planet's axis? Okay. Now, it also includes the sun, right? So, for the sun, it takes 27 days, right? Mercury is 59 days. Venus is 243 days. Keep this in mind, right? It's a long period of time for Venus. Okay. Earth is approximately 24 hours, right? And Mars is just a little more than 24 hours, right? So it's very similar. And then as you go into the gas planets or the outer planets, notice the time of revolution is shorter, right? So instead of days, it's hours. Now 9 hours and 50 minutes. Saturn, 10 hours and 14 minutes. Uranus, 17 hours and 14 minutes. The next column is the eccentricity, right? So the eccentricity measures how oval the shape of a planet or celestial object is. Okay. So in other words, um, the orbits, the shape of the orbits of the celestial objects in the solar system is not a perfect circle, right? It tends to be elliptical. The eccentricity tells you how elliptical or the degree of how it's elongated, if you will, right? So the higher the value, so for example, Mercury, the more elliptical it is, right? It's more elongated. Whereas a smaller value, or the one that's maybe closer to one, for example, Mercury, it's 007, right? That means closer to a circle. Okay, so there isn't a direct relationship between the distance from the sun and an eccentricity, right? It's really uh, based on that particular planet's orbit. Then you have the equatorial diameter, which is basically the width of the planet at its equator, how wide the planet is. Couple of things to be mindful of. Um, Venus and Earth has a very similar equatorial diameter. That's why they say Venus is considered Earth's sister planet. Then you have Mars, which is roughly half, okay, roughly half more or less of Earth's, okay, and then you get into the outer planets, which you see the equatorial diameter in general are much larger compared to the inner planets, okay, and so yeah, so depending on the questions or how it's being asked, okay, key things you would look out for, the key words: mean distance from the sun, period of revolution, the period of rotation, eccentricity of an orbit, etc., etc. If there's questions that mention these terms, take a look in the reference table. The answers might be there. Okay, or any type of data, information, or relationship between the distance from the sun and the period of revolution. or just the characteristics of the planets in terms of their rotation or equatorial diameter, it's right here. So use this to your advantage. I hope this was helpful, and I will see you in the next one.